Hello everyone! Today we are going to explain the entire history of astronomy in just 8 minutes. No pressure, right? Let's dive straight in. The ancient sky and the naked eye. For thousands of years, humans looked up at the night sky and saw a beautiful mystery. Our journey doesn't start with high-tech telescopes. It starts with pure curiosity and the naked eye. Thousands of years ago, the Babylonians and Egyptians treated the sky like a giant clock. They tracked the movements of the sun and stars to predict when rivers would flood and when to plant crops. To them, astronomy wasn't just a science, it was survival. For early mathematical models, we travel to ancient India. Around the year 500, a brilliant astronomer named Aryabhata proposed that the Earth rotates on its own axis every single day. He also accurately explained that the moon and planets shine by reflecting sunlight, and he figured out the true cause of solar and lunar eclipses. Meanwhile, in ancient Greece, Ptolemy formulated the geocentric model, claiming the Earth was the absolute center of the universe. Everything else revolved around us in perfect circles. Even though he was fundamentally wrong, this idea was so convincing that it dominated human thought for the next 1500 years. The Islamic Golden Age. During Europe's Dark Ages, the flame of astronomy was kept alive, polished, and drastically improved in the Islamic world. Between the 8th and 14th centuries, Muslim astronomers set up massive observatories and revolutionized how we calculate the cosmos. Enter al-Battani, who corrected Ptolemy's old calculations. He recalculated the length of the solar year with astonishing precision, getting it down to 365 days, 5 hours, 46 minutes, and 24 seconds. That is incredibly close to our modern satellite measurements. Then came Abd al-Rahman al-Sufi. In 964, he published the Book of Fixed Stars. He was the first person to look closely at the constellation Andromeda and notice a faint blurry cloud. He called it a small cloud. He was actually looking at the Andromeda galaxy, the furthest object visible to the naked eye, containing 1 trillion stars. We also can't forget Nasir al-Din al-Tusi. He created a brilliant mathematical device called the Tusi couple, which explained the complex, irregular movements of the planets. His advanced geometry cracked open old astronomy and laid the exact foundation that European scientists would copy centuries later. The telescope and the Renaissance rock stars. In the 16th century, the universe got completely flipped upside down. Polish astronomer Nicholas Copernicus looked at the complicated math required to keep the Earth at the center and asked, what if we just put the sun in the center instead? Boom! The heliocentric model was born. It was simple, elegant, and changed everything. But ideas need proof. That proof arrived in Italy with Galileo Galilei in the early 1600s, who pointed his telescope at the sky and discovered moons orbiting Jupiter. Meanwhile, the Ottomans were running their own cosmic race. In the grand observatories and bustling shipyards of Istanbul, Turkish scholars and navigators were quietly mastering celestial mapping, combining advanced mathematical astronomy with navigation to chart both the horizons and the stars with incredible precision. Shortly after, German mathematician Johannes Kepler realized that planets don't move in perfect circles, but travel in stretched out ovals called ellipses. Finally, Sir Isaac Newton tied the whole package together. He invented the reflecting telescope and discovered universal gravitation, explaining that the same force making an apple fall holds the moon in its orbit. Before we break the light barrier and look at what stars are actually made of, if you're enjoying this cosmic journey so far, take a quick second to hit that subscribe button and turn on notifications. It really helps the channel grow, and you won't miss any of our upcoming deep space adventures. Done? Awesome. Let's head into the 1800s. Breaking the light barrier. By the 1800s, telescopes were getting bigger, but astronomers realized that just looking at the shapes of objects wasn't enough. They wanted to know what the universe was actually made of. This brings us to a massive breakthrough in Germany, where scientists developed spectroscopy. By passing starlight through a prism, they could see lines of color, like a chemical barcode. Suddenly, we didn't have to guess what stars were made of. We could read their chemical signatures from millions of miles away. In the United States, a group of brilliant women known as the Harvard Computers changed the game. Annie Jump Cannon analyzed the spectra of hundreds of thousands of stars, creating a temperature-based classification system we still use today. Another American astronomer, Henrietta Swan Leavitt, discovered a unique relationship in pulsating stars, giving humanity its first cosmic yardstick to measure the actual distance to faraway stars. The expanding universe. Armed with these new cosmic yardsticks, the 20th century completely exploded our understanding of scale. Up until the 1920s, scientists believed that our galaxy, the Milky Way, was the entire universe, wrapped inside one single island of stars. But in 1924, American astronomer Edwin Hubble, using the world's largest telescope at Mount Wilson, looked at those faint clouds that Al-Sufi had spotted centuries earlier. Using Leavitt's yardstick, Hubble realized these clouds were way too far away to be inside the Milky Way. They were entire galaxies of their own, and Hubble wasn't done yet. By analyzing the light from these distant galaxies, he noticed something even more mind-blowing. Almost all of them were rushing away from us. The further away they were, the faster they moved. This meant the universe wasn't static, it was actively expanding. This matched perfectly with the radical new physics developed by Albert Einstein, whose theory of general relativity showed that space and time are flexible fabrics that can stretch, bend, and warp. If the universe is expanding today, it means if you rewind the cosmic movie tape, everything started from a single, infinitely dense point. This gave birth to the Big Bang Theory, the space race, and the view from above. By the mid-20th century, humanity was no longer content with just looking at space from the bottom of our atmosphere. We wanted to go there. The Cold War kicked off the space race between the United States and the Soviet Union. In 1957, Soviet engineers made history by launching Sputnik 1, the very first artificial satellite, into orbit. The world listened in awe to its simple, repeating radio beep. Just a few years later, in 1961, Soviet cosmonaut Yuri Gagarin became the first human in space, orbiting the Earth and proving that humans could survive outside our home planet. The United States responded with the ultimate lunar goal. In 1969, the Apollo 11 mission successfully landed humans on the moon. Neil Armstrong and Buzz Aldrin walked on another celestial body, giving us a completely new perspective on our place in the solar system. The modern cosmic frontier. Once we conquered the edge of space, we started putting our best instruments directly into orbit. In 1990, NASA launched the Hubble Space Telescope. Operating above the distortion of Earth's atmosphere, Hubble captured the most breathtaking, crystal-clear images of deep space, allowing us to calculate the age of the universe at roughly 13.8 billion years. But the universe still had secrets. In the late 1990s, astrophysicists discovered that its expansion isn't slowing down, it's speeding up. This acceleration is driven by an invisible pressure called dark energy. Along with dark matter, which holds galaxies together, we realized everything we can see makes up only 5% of the universe. The rest is completely invisible. Today, we live in the golden age of astronomy. In 2021, the world launched the James Webb Space Telescope. With its massive infrared mirrors, Webb can peer through cosmic dust clouds to see the very first galaxies forming after the Big Bang, while simultaneously sniffing the atmospheres of distant exoplanets to look for signs of alien life. If you enjoyed this fast-paced journey through the stars, make sure to hit that like button, subscribe for more deep space content, and let me know in the comments, what do you think is the most exciting mystery left to solve in astronomy? Thanks for watching, and as always, keep looking up.